Hello everyone, welcome to another video. Today I want to talk some misconfigurations in Azure I see more and more lately that can cause a major security problem and also give, for example, your ex-employees access to your Azure resources. So the plan for today is that first I want to talk about static credentials. That's for example an access key or a connection string. Then I also want to talk about the network configuration. Many Azure services have a firewall, and this firewall often is not configured or configured in a wrong way, and Microsoft is also not helping here with the settings. After this introduction, I'm going to show you how such an attack could look like. In this case, I'm posing as an ex-employee who still has access to the passwords, and I will show you how you can easily go around the firewall and access a database. After this demo, I'm going to give you some recommendations how you can keep your environment and your application safe. So now let's get started. First, what are Azure credentials? There are many different credentials we have. It depends on the service. So often with access keys, for example, in storage accounts. Then we have in the Azure Container Registry, the admin user. That's basically a username password. And with this, we can log in into the Azure Container Registry and do everything in there. Then we have shared access policies. That's often used in IoT Hub, Service Bus, Event Hub. It's the same as the access keys. You can define the permissions. They're usually manage, send, and listen, or in the storage account, just to manage and see files. And once you have them, you have access to the resources. In the SQL Server world, we have SQL authentication. This means on our SQL server, we just log in with username and password, and then we have access to the databases. The same with Postgre. There, I think it's called PostgreSQL authentication, but it's the same. We have a username and password, and we can log in with that. This means if I'm leaving the company and nobody changes the passwords, I still have access to the passwords, or I still know them. And that's the big problem. But one way to solve this, or at least mitigate it, is to have a firewall and block everything that's coming from outside the company network or outside of our Azure environment. But the problem is this firewall is often misconfigured. By default, it's often configured with just allow every public network to access it. The reason for this is it is easy. You don't have to configure anything, you just give access, the developers can access the service, and everything works. Then you have the option to only allow selected networks. That's already better, because you can configure, for example, I only want to allow my company network and some VNets in Azure, and this network should have access to my resource. Additionally, I can allow IPs. For example, if I work from home, I want to allow my personal IP address so I can also do the work and access the service. The big problem with this is there's one setting that sounds very helpful but can be really bad. This setting is usually visible when you select the selected networks configuration in the firewall, and the wording varies a little bit service by service. In the SQL Server, the setting is called Allow Azure Services and Resources to access this server. This sounds very helpful, like you activate the setting and your other Azure services have access to the SQL Server. The problem is that this means every Azure service. This doesn't restrict to your subscription or tenant. So for example, if I'm a former employee, and that's what I'm going to show you later, I can create my own virtual machine in my own tenant. I just enter the publicly available URL, the username, the password, and I will go around the firewall and have access to the database. So I really hate this setting because it makes you think it is secure and just easy to configure your firewall, but it basically opens it up to everyone that has an Azure account, which can be literally anyone. In other services, like the Azure Container Registry, it is called Allow Trusted Microservices to access this container registry. And in the storage account, it's called Allow Trusted Microsoft Services to access this resource. There's also, for example, for the Azure Key Vault, but the outcome is always the same. and it's always on the bottom of the settings page. With this said, now let's switch over to the Azure portal and I'll show you how the credentials work, where you can find them, and also how you can configure our services to keep them secure. Alright, here in the Azure portal, I have already a couple services prepared for you and I will go through them one by one and I will show you what the potential problem could be and what solution we will have. The first one I want to show you is the IT Hub. If you scroll down a bit on the left side, we will see here shared access policies. If they are enabled, then by default you have a couple shared access policies. For example, here the IoT Hub owner. If I click on this, I will see the primary key, secondary key, and with the combination of the name of the IoT Hub and one of the keys, I can create the connection string. And then depending on the permissions, I can do whatever this shared access policy allows. In this case, we can see it allows for everything. So I can connect my devices and I can also send messages. If let's say I'm a former employee, I had access to his primary keys, and if nobody changed them after I left the company, I still know them. This means I could set up my own device, connect it to the IoT Hub, and then send malicious packages or some messages that might mess up the infrastructure. Let's move to the next service. So first I'm going to show you what the problem are, and then in the end I'm going to show you how we can solve them. Every service will be quite similar, but there are also some tiny differences, but we'll see. So the next service I've prepared is the service bus. Here we also have shared access policies. By default, we just have one, but it's the same as before. So we have here a primary key, a secondary key. With this, we can create the connection string, and the default shared access policy has access to everything. This means I can send messages and I can also listen to messages. The next service, Event Hub, works exactly the same. So I have one shared access policy and again, primary key, secondary key, and I can use them to connect to the Event Hub and also send or listen to messages. The next one, the container registry, is a bit different because here we don't have shared access policies, but we have an admin account. So if we go on access keys on the left side, we can see here the admin user is enabled. And we can also see here the password of this admin user. Once I have this information, I can just do a Docker login. I provide the name of my Azure Container Registry. And then I provide the username and the password, and I have access to this container registry. I also have access as full admin. This means I can download images, I can upload them, but I can also delete them. Then the next service is the storage account. So here it works a little bit different. So if you scroll down, we have access keys. The principle of access keys is the same everywhere. Here we have again two keys. Instead of primary, secondary, they're called key 1, key 2. But here you can see we have the password, and with the name plus password, we have our connection string. What's great about storage account is that we can just change them with one button click here, and we can also see when it was changed the last time. So it was 1 day ago or 0 days ago because I created the storage account today. If you see here a big number like 1,000, even more, then you know that the password hasn't changed in around 3 years or even longer. The last service I want to show you is the Microsoft SQL Server. This again is a bit different. So if we go to Microsoft Entra ID, we can see here that we don't have an Entra ID admin set, and we also don't have the setting support only Microsoft Entra authentication for the server. This means we allow SQL authentication. This means we have a username and a password. And again, if I know the server name, I have the username, I have the password, I can log in. To show on the properties, I can see the server admin login. So I already see the name, and since I'm a former employee, I worked with the system, so I had the password most likely, and this means I have access to the server. When I say I have access to these resources, this is only half true. So right now we have seen I have the access keys, password, whatever you want to call it. But there's a second option you can have to protect yourself, and this is the firewall. The problem is the firewall of these services is often either misconfigured or there's a setting that sounds helpful but is not helpful at all. So let's go back through our services, and now let's take a look at the firewall configuration. So here in our IoT hub, if we click on the networking configuration, here you can see we allow public access to all networks. This means everyone can connect to our IoT hub. It would be better if we could disable the public access or at least select the IP ranges. And here you can also see that Azure already suggests public IP address. This is more secure, but the downside of this approach is the way how the IoT hub works. Usually I have all my IoT devices somewhere outside of Azure. They could be at plants, factories, with remote workers, but not in Azure. So if I want to block the IP address, I would have to allow the public IP address of all my services. That's usually not feasible. So with the IoT hub, restricting the network access is often not a great solution. There are obviously ways around, but it needs more work and it's more complicated. So for now, I want to focus on the quick wins. And with this, we take a look at how the authentication works. As I said before, we have the shared access policies, and there we have the access keys. This means the password, and I can connect to the service. So in Azure in general, a best practice is to use matched identities. So every time you see an access key, a shared access policy, something like this, this should make you think that something is misconfigured or maybe the configuration is outdated. And you should use matched identities. The reason why is matched identities don't have a password that needs to be rotated or could be stolen. Microsoft takes care of the passwords in the background and you never see them. And this means a developer never has access to them. So if I leave the company, there's no password I can take with me to access the resources. The way it works is usually a service has an identity. And if I click on the tab, I can just activate this identity. So I save it. Now Azure takes care to create a new identity and assigns it to the IoT hub. This means my IoT hub now has an identity and I can give this identity a permission to access another service. If I want other services to be able to access my resource, I can just give them permissions the same way as I can give them to the users. So I have here the access control, and here I can just add a new role assignment. Then once the list is loaded, I have a list of all the roles I can give. So hopefully this doesn't take too long. Actually, it took forever and I had to cut the video here, but now we have all our permissions. So I can select the permission I want, in this case, the reader role. And here I can now select, do I want to give this permission to a user or a group or to a managed identity? So I can select managed identity. And when I click on select members, I can select all the identities I have in my permission. So in this case, we can see I only have one for my Kubernetes cluster. So I can select this cluster. And if I click on review and assign, actually let's do this, then my Kubernetes cluster now has the reader role on the IoT hub. And if my AKS cluster wants to access the IoT hub, there's no password involved. It just works with these permissions. Here again, the IoT hub is a bit special. Because all my IoT devices are running outside of Azure, I can't give them an identity. But with the IoT hub in this case, I can use certificates. So I can provide X509 certificates. Every device gets its own device, and then they can use this certificate to connect to my IoT hub. With this approach, I don't have any passwords, nothing can get stolen, and the access is secure. With this said, now let's go to the next service, the service bus. And if we take a look here at the networking tab, we can see that we have either access to all networks or selected networks. With the selected networks, again, it asks me to add my IP address, and then only this IP address has access. Overall, the best approach would be to have a private endpoint. And the way it works is this private endpoint would create a network card and attach it to the service bus and to a VNet. This way, the service bus gets a private IP address assigned, and additionally, there will be a private DNS zone, and this private DNS zone overrides public DNS entries. So if one of my services is in the same VNet and wants to access the service bus, then I can just call the public URL or name, and the private DNS zone will redirect the request to the private IP address of the private endpoint. This way I can keep my applications or my services secure, and I don't have to change too much in my other applications because they can just reuse the same name. But as you can see here, we don't have the option. And here the service bus is a bit weird because I'm using the standard tier because it costs something around 20 or 30 US dollar. And if you want the private endpoint feature, it costs over $600 for the premium tier. So unfortunately, Microsoft sometimes puts security features behind the premium tier, which can be really expensive. And for the service bus, it might be too expensive for many teams. Especially if you get rid of your shared access policies and only use managed identities. This means all the services within Azure can authenticate with their identity. There's no password. And in this case, this might be the better solution. Obviously, if security is very important for your project, for your application, then this is a cost you might have to take. If I take a look now at the next service, the Event Hub, there again we have the networking tab, but here we can see we have the public access and the private access. So if you take a quick look at the private access, here we could create a private endpoint, and then we can connect to the Event Hub over a private connection. Maybe it was a bit fast when I explained the private endpoint before, but I have a video explaining it step by step. I'll put it in the description, but it also showed that there are a lot of steps involved. And if you want to improve your security, or just in general in software development, you want to improve something, try to do it in small steps. Start somewhere small, make a tiny improvement, and then go from there. So in this case, instead of going all private right away, let's restrict the public access. So if we click on the configuration of the public network access, there we can see it is enabled, but we can also select between enable from all networks or enable from selected networks. Here we have configured enable from selected networks. That's already an improvement. And once you enable this, as you can see here, you have more options to configure what you want to enable. So here you can either say, I want Azure VNets. In this case, I haven't added one, or I can add a public IP address. So here you can say I added the IP address 1234, and then this public IP address can access the service. This is great as a starting point, but there's one problem. So if we scroll all the way down, there's this one exception. and it's called Allow Trusted Microsoft Services to Access this resource. This sounds like a really useful service configuration, because I often don't know the public IP address of my services. For example, if I have an Azure App Service, I don't know their public IP, except if I configure it, which can be a bit complicated. So if I enable this to allow the trusted services, everything seems great. But the big problem with this is that it allows the public IPs of Microsoft, of any Microsoft service within Azure. So this means it's not restricted to your subscription or even tenant. Anyone can create, for example, an Azure VM and then access your service, because the Azure VM is a trusted Microsoft service and it will bypass your firewall. I'm going to show you this a bit later in a demo, that even though we have the firewall enabled, we can just go through it as if it wasn't there. So this is a setting you should always disable. With this said, now let's take a look at our container registry. There again, we go to the networking tab. Here we also have the public access and the private access, because I'm using the premium tier again. But for the container registry, the premium tier is around $50 US, so that's way more reasonable than more than 600 for the service bus. You also have the option here, if you want to allow all networks or selected ones, or disable the public access in general. Again, if you want to do step by step to improve your security, just restrict it from all networks to selected. This already helps a lot. And then we can add IP addresses. And down here, we again have this very bad setting. With the container registry, it's named a little bit different. So in this case, it's allow trusted Microsoft services to access this container registry. And again, if I have my admin account enabled, someone knows the username, the password, then they can just access the container registry. All they have to do is create a Azure VM or any other Azure service, and it will bypass the firewall. So if you have this setting enabled, it's basically not having any firewall at all. The same for the storage account. So if we scroll up in this case to the networking tab, here we have the same as before. We can enable private endpoints, and we also can restrict our public access. If you click on this time we allow, again, public access is enabled, but we restrict the networks again. If we scroll down, as we've seen before, we can add VNets, we can add a public IP address. And in this case, if you scroll all the way down, we have even more exceptions. This means in this case, it's allow trusted Microsoft services to access resource. Again, if I have an Azure VM, I can just bypass the firewall and access it. But then additionally, we have allow read access to storage logging from any network, and also allow read access to storage matrix from any network. This means any network can read the logging and metric information of the storage account. So again, that's very bad, and we want to make sure that all of this is disabled. Lastly, we have our SQL database. Again, we scroll down to the networking tab, and here also we have public access and private access. What you have seen before. A bit of a problem, but it's also good for security in a way, is with the public access, we only have the options between disabled or selected networks. So we can't say we want to allow it for all networks. So with the selected networks, we have to provide a VNet or an IP address. As you can see, I have nothing provided. This means I would guess that everything is blocked. But again, with our bad configuration down here, in this case, it's called allow Azure services and resources to access the server. And in a minute, I will show you that if I try to connect to the SQL server from my local machine, it won't work because I don't have an Azure trusted IP address. But if I create a virtual machine and I try the same, I will just get into the server and can do whatever I want. I said before that all network access is disabled. What you could do is you add a firewall rule, you give it a name, for example, all network access, and then you start with 4 times 0 and you give it the end IP of 4 times 255. And now you allow all IPs to connect to your database. But I hope you know, and it's obvious, that that's very insecure, so you don't want to do this. Right now, as you can see, we don't allow anything to access the SQL Server. But now I'm going to switch over to first my local machine, then my Azure VM, and we'll test the access. Also, I'm using an Azure VM that's not inside my tenant. So if I go back to all my resources and I open here the virtual machines, you can see there's no virtual machine. I've created a VM in a different tenant. Since it's a different tenant, I can't show you all the details, and so you have to believe me, it's an Azure VM, but we'll see that I connect to it via RDP, and from this VM we'll be able to access our database. With this said, now let's switch over to Visual Studio Code and try to access the SQL Server from my local machine. Here in Visual Studio Code, I'm using the Microsoft SQL extension, but you can use any SQL tool you want. The way it works here, I click on Add Connection, I provide a name. If I scroll down, I provide the server name. This is just the name of the server, .database.windows.net. Since I pretend I'm a former employee or former team member, I remember the server name. For the authentication, I use SQL login, then I use the name, the username, and I'll hopefully remember the password as well. That's everything I need. So if I now click on connect, I should get an error message because my IP address is not approved on the firewall. It took a couple seconds, but now it tells me I don't have access, and it also asks me if I want to add my public IP address to the firewall exception. I get this message because I'm the owner of the SQL Server. I'm logged in with my account, as we can see here. If I don't have an account, if I'm, as I said, a former employee, I won't get this error message. Also, in case if you are wondering about the public IP, I'm using a VPN server, so that's not my real public IP. Now, this didn't work. Let's switch over to an Azure VM and then try the same thing again. Here in my Azure VM, as you can see on the top, I'm connected via RDP connection. Again, I've opened Visual Studio Code. We again click on add a new connection. We provide a name. We provide the same server name as before. Now if we scroll down a bit, we have SQL login. Then we provide the username. And we also provide the password. If you scroll all the way down now, we're gonna click on connect, and this time I expect it to be working. So it should take a couple seconds, and as you can see, we are logged in the server. Although it should be blocked by the firewall. But since the one setting to allow trusted Azure services is enabled, the firewall trusts our VM. Even though it's running in a completely different tenant, it has no association with the SQL Server, with my company. I can access it. And now I can do whatever I want on the server since I have the root or the admin username and password. Now let's switch back to the Azure portal and let's take a look what we can do to make our applications and our services secure. Back in the Azure portal, most of the configurations will be very similar, so it's going to be a bit repetitive. It might just vary a little bit depending on the service. So the first service we have here is the IoT Hub. And as I said before, with the IoT Hub, we can't really use matched identities for our devices. So you want to use certificates. But what we also should do is, if we go to the shared access policies, we want to disable them. The way it works is we have here the setting connect using shared access policies. If we deny this, then it will deny any connection with a shared access policy. So it doesn't matter if somebody knows the password or the key, it just doesn't work anymore. So if we save this, then it's going to block all the connections with shared access policies. This is already a great first step to increase the security, especially with the IoT Hub. As I said, with the firewall, it can be a bit tricky the way IoT devices work. So if you disable this and you have your devices using certificates, you're already way more secure than before. Then the next one is our service bus. Here it's a bit tricky because if you go to shared access policies, then we don't have any option to configure anything. We can only add new ones. So it's a bit hidden on the overview page. And I say hidden even though it's right in the middle there, but it's something that's overlooked often. It's called local authentication. If you click on it, it asks you if you want to enable or disable local authentication, and this means shared access policy key authentication. So if you disable this, then the same thing as before happens. The shared access policy login won't work anymore. So it doesn't matter if an attacker has the password, the access keys, they just can't log in anymore. And with the service bus, I can just use manage identities, and my applications now can access the service bus in a secure way. Additionally, I want to take a look at the networking, and here is the problem with the tier. As I said, service bus needs the premium tier, which is really expensive. So if you don't have special requirements for security, it's probably good enough to use managed identities and leave the network as it is, because the costs are just exorbitant. If you are a very big project where $600 a month don't matter at all, then obviously it's recommended to have a prior connection, but many teams don't need it. Next, now it's getting a bit more interesting, I think. If you go to the Event Hub, it works the same way. So if you go to shared access policies, we don't see anything to configure here, but on the overview page, we also have here the local authentication. If we click on it, we can also disable it here. This means the shared access policies are not able to log in anymore. From now on, I only use managed identities, and this will keep my applications secure. Additionally, if I now go to the networking tab, I can see I can configure the network in a way better way than with the service bus. I also said before, if you make any improvements, make it step by step. So switching from shared access policies to managed identity is already a major step, and it will improve your security probably by 99%. But also we want to make sure that everything is secure. So there's the principle of zero trust, which means we don't trust anyone and we want to verify everything. So having an identity is a great first step, but we also want to verify our network access. And this could be the next step. So what you can do is take a look at the networks, and you want to restrict who has access. So a great first step could be to enable from selected networks only. The problem is that the services that want to connect to the Event Hub now need to be inside these VNets. If you already have this, then it would be great to enable. The biggest change you can make is to make sure to don't allow trusted Microsoft services to access this resource, because as we have seen, everyone can access, in this case, the Event Hub. Since we just switched to managed identities, it's way more difficult now, but still we want to be safe. The best solution, but also the one that needs the most work, would be to enable a private endpoint. And I think I said it before that I have a dedicated video for this where I show step by step how I can enable it. But why I said it should be the last step is it's the most complicated. First, you have to understand how it works. Then you need your own VNet. This means you have to design the IP of the VNet, and also all the services that should access your event hub have to have access to this VNet or be in this VNet. This means it might need some change for all the applications you are have in your service and that have access to the event hub. From a security perspective, this is obviously by far the best solution. Then our next service, the Azure Container Registry. That's again a bit of a special service. So we don't have shared access policies. We have our admin user. So the first step would be to disable this admin user. And now we use managed identities to give permissions to, for example, download our images, or maybe for a pipeline like an Azure DevOps pipeline to upload new container images. So as I said before, we can just go to access control and add here a role assignment for a managed identity. But sometimes you want to be more specific with your permissions. For example, if you have a Kubernetes cluster, you can give this entire Kubernetes cluster permission to pull images. But sometimes you want to give one application inside your Kubernetes cluster access to download maybe one specific image and nothing else. By now, we also have a way to add managed identities to our applications inside a cluster, but it needs to become configured. Also, if you go back to our IoT hub example, our IoT devices are running on-premise, so they don't have identities. So they also need to authenticate and download images. And the best way to do this is using a repository token. So if we scroll down on the left side, we will find here the tokens. And this is basically a username password combination where you configure what permissions this username and password have. So if you create a new token, then we provide a name. Then here we already have predefined permissions. For example, the admin can do everything. The pull can only download images. The push can upload images. But you can also say, I want to read or write metadata information. If that's not good enough, you can create your own permissions. You can ignore this error message. It's just because my IP address is not enabled on the firewall. But here you can say what repository. For example, if you have an Nginx repository, then you can select exactly what permissions. So I only want to read the content and the metadata, for example, but no delete or write. And once you have to configure this, let's just say in this case, we want to allow the pull permissions. We create this token. Should only take a couple seconds. And after this token is created, we can see here, we don't have a password generated. If we click on the token, we can here generate a password. We can also set an expiration date. For example, that the password should expire after 1 month automatically. That's in general a good approach, because if somebody steals the password, it will expire automatically and nobody has access anymore. But for now, let's leave it as it is. We generate a new password, and here we can see now our password. Also, we see the Docker login command. It is Docker login, then as the username, the name of the token, and as the password we just created. With this, you can log in. Also, what's great about this token is if I close this window now, I cannot see the password. This makes it way harder for somebody to steal the password. So if I want to have the password, I have to regenerate it again. So I have to create a new password, and this also makes the old password invalid. And so I think that's everything about the access. So in general, use managed identities wherever possible. If you can't use managed identities, use these token repositories. For the firewall, if I can find the network tab, it's what we have seen before. We have the public access and the private access. Private access is only available for the premium tier. That's fortunately not too expensive. And we also have, for the public access, our horrible setting. In this case, it's called allow trusted Microsoft service to access this container registry. So you should disable this because, as you have seen, it gives access to literally anyone. Then the next service we have is our storage account. Here again, it works a little bit different. So if you go to the access keys, we don't have any option here. We can just rotate the access keys. So we have to scroll down a bit to the configuration tab. And here we have a setting to disable these access keys. So once the page is loaded, we will disable it. It's this one here, allow storage account access. Once we disable this, it also tells you that every login with this access key will just fail because it's invalid. So again, it doesn't matter if somebody has the access keys. From now on, the login won't work, and I can give out managed identities to my Azure services, and they can use these identities to access the storage account now. From the firewall, it's the same as we've seen before under the networking. We have the private endpoints, which are amazing from a security perspective, and for the public access, we can again filter for the networks, IP addresses, and we have to make sure that we disable this allow trusted Microsoft services setting, so only our services can access the storage account. Lastly, we have the Microsoft SQL Server. Here again, it works a little bit different. So if we go to Microsoft Entra ID, we can see we don't have any Entra admin configured. So what we have to do is first set the admin account. And once the admin is set, then we can disable the secret login. To do this, we click on the top on set admin. Now we can search for a user or a group. But I think that's a bug or a misconfiguration in the Azure portal, because you can only assign one user. If you assign a group, it will select the first user of this group. I don't know if this is working as intended or if you're supposed to add a group. If you know this, let me know in the comments, but this is what I've experienced in the past. So now let's search for my user and add it as the administrator of the SQL Server. Here's my user, let's add it. And now I can also enable this setting, support only Microsoft Entra authentication for this server. This means the SQL authentication will be disabled. And this again means that what we did before with creating an Azure VM, then using the SQL user and password won't work anymore. So now we haven't changed anything on the firewall. It was only a quick change and it increases the security tremendously. In reality, it might need a bit more work because you have to enable the managed identity for all the services that should access your database. You have to give them the right permissions, and then you can switch over to Entra ID only. In general, please always use managed identities. It makes your life so much easier and so much more secure. But for now, let's take a look at the networking configuration of the firewall, and then we're done for today. Here, it's basically the same what we've seen before with the private access, amazing for security. And we also have the public access where we can also restrict virtual networks and IP addresses. And again, we want to disable this setting. Once we save this, then we can really control that only our services have access to the firewall and through the firewall to the SQL Server. As I said before, right now, none of our services will be able to connect, even if they have the right permissions, but their IP address will be blocked. So it will take a bit of work, and with the managed identities and Entra ID, it's already a lot safer, but also take a look at the firewall to make sure everything is secure. I think I'm quite repetitive today, and this also is the end of what I wanted to show you. But please use managed identities. It's so much more secure. And also, if somebody leaves the company, you don't have to change anything. You just deactivate their user account and everything else should stay safe. As you've seen in the example today, if every service has some access keys, username, password, you would have to change everything and it's very insecure. With this said, now let's switch over to my presentation and just summarize what I showed you in the Azure portal. Now let's summarize. So we had two problems we looked at. First is the static credentials and the second one is the network configuration. So with the static credentials, the best solution and the best next task you could implement is switch over everything to managed identities. It makes your life so much easier and so much more secure, and it will also help you in the future. For example, if you have access keys and somebody leaves your team, then you rotate them right now. But if somebody leaves in 1 month, you have to rotate them again. And if somebody else leaves in 6 months, you have again to rotate the keys. If you have managed identities, you just deactivate the user account and everything is good. So if you don't have too much time, just try to take a look at managed identities. Something I haven't mentioned today is sometimes, even if you want to use managed identities, you have secrets you have to store. For example, if your software is connecting to a third-party tool and the API only allows access via an API key, then you have to make sure to first store the secret in a secure way. In Azure, we use the Azure Key Vault. In my opinion, developers shouldn't even need access to the Key Vault because everything can be done via automation. If the developers need an API key for some testing, then you should have a test instance with just fake data, no real permissions. And if somebody still has the key, it's not great, but they can't do any harm with it. Anyways, of what solution you go for, make sure to regularly change the secrets. The problem is also you don't know if somebody stole or leaked the secret. This means somebody could access, in this case, your API, and you don't even know because they have a valid API key. But if you change it, let's say once a month, then the access will be cut off after a maximum of 1 month. In Azure, we can everything automate. It takes a little bit of work, but the Azure Key Vault allows a function to automatically rotate your secrets. There are events when secrets are expiring, and you can also have an Azure DevOps pipeline to just update the secret in the Key Vault and also the references if you need to. Another step that's often overseen is you have to have a process when somebody leaves the company. Usually HR has some basic processes, for example, deactivate the user account, fill out some documents, and that's it. But if you have a user that's not linked to Entra, for example, if you use a third-party tool that doesn't allow single sign-on and the user created an account there, then this account won't be disabled. So you have to know that this account exists and disable it by yourself. Next, we also have the network configuration. So as I said before, if you switch over to managed identities, it's a major improvement and you are very secure already. But still, we should make sure that we have security in all aspects, and networking is one of that. So the biggest change you can make here is you disable one of the settings that allow trusted Microsoft services. The wording varies, but it's always on the bottom under the exceptions headline of the firewall setting. If possible, the best solution would be to use private endpoints, because this means your resources are only available over a prior connection. And here you could also prioritize your most important resources. The first thing that comes to mind is an Azure Key Vault, because it contains all the secrets, passwords, so you want to keep it as secure as possible. The second service might be a database, especially if you store customer data, some sensitive data. You also want to make sure that this data is secure as possible. Lastly, one problem or challenge is if you have private resources, the deployment gets a bit more complicated. So if you want to create resources, for example, a SQL server, that's no problem at all. But if you want to access something that's behind the firewall, for example, a database or the secrets of the key vault, then your Azure DevOps agent or whatever tool you use, for example, a GitLab runner, a GitHub runner, then they need to be inside the VNet to access the private endpoint. With Azure DevOps, we've managed DevOps pools, which is an amazing service that makes it very easy to have your own agent inside a VNet. If you're using a different tool, then you have to manage it yourself. So the solution is often to have a VM where you host your agent, or you can have a container deployment where you host it, but it's a bit more work. I have an entire video about this. I will link it in the description. It's just important for me to know that once you decide you want to make the changes, that you have to properly plan it. That's everything I want to show you today. So to summarize everything, use managed identities, don't use static credentials, and if you have to use them, make sure you rotate them regularly. And also take a look at your networking settings to disallow the access to trusted Microsoft services, because this can make it very easy for attackers to get around the firewall and access your service, especially if they know the username and password. With this, I hope you stay safe, and I will see you next week with a new video.